This with WD-40. All right. Whoa, my gosh. You're just there. Look at Carrie. I'm gonna get this. I know Jeff's coming right now. Luke just got this thing. This is fresh. This is fresh on assembly. Fresh on all the welding done. All this stuff doesn't have WD-40 on it yet, so I'm gonna juice this. Sometimes you guys have asked what we use to preserve the metal, and I can really give you some opinion oil on that because we've used a couple different things. The one Fast Flores recommended to me was avocado oil, right? And we did the avocado oil at off-road or at Sand Sports show. The problem with the avocado oil is it does dry. And when you're like, the thing is, usually if we're preserving these, we're only preserving them until they're done, and then we're gonna coat stuff. You know, so the thing that sucks is if you're mid-build and they put like a coating on there, it's extremely difficult to get it off, especially in tough areas, and it literally dries into this thing. It's very similar to linseed oil. That was my first thing. So that truck over there, that was the first truck that I built, and I was so in love with heat marks and how these things look, you know, raw, and showing all the haze, the heat affected zone, that I really wanted to preserve it. And I'm like, I'm gonna roll this daily driver around with a raw bed cage. And I mean, essentially that, look over there, it's all sandblasted, but that's pretty much a full back half at that point. So every time it would, originally I put linseed oil on it. What a stupid tangent, but whatever. We're gonna just get this thing cherry for you and for Jeff. Originally I did the linseed oil and it was gnarly. It almost was like a shellac, like a wood clear coat that you'd put on a deck or something. And it was, I did it early on the build, so then when I'd go to weld, it would kind of like fry the area that had the clear on it, and it was next to impossible to get off, even using acetone or something. So I 86 that early. The avocado oil taught me a pretty good lesson when we got the Range Rover back from Sand Sports and Off-Road Expo. And I said, nope, we're not doing that again. And then, you know, I used to think SC1 was the absolute ticket, and it smells really good. But SC1 does not work well for transport conditions, beach conditions, anywhere where you're gonna leave something at a show and there's some kind of precipitation in the air. Just doesn't work well. SC1 does not last well. So I think if the cars, you know, I think like Mason Motorsports, their trucks pretty much don't go and get displayed. They bang those things out. They sit in the shop until they're done, so they preserve them. They preserve them with SC1, and that's a win. But, you know, the number one thing we just keep going back to is good old WD-40. And it comes off easy. It's inexpensive in comparison to SC1. There's no hassle. There's no big, you know, loss you take when you have to clean the area up from, you know, it doesn't affect your welding or contamination. So if you guys, you know, that was 5 minutes straight of telling you that we use SC1 or that we use WD-40. talk about this, I can still wipe it down. I think the last time that we went over this, it was bare. It didn't have the cross member in yet, right? We talked about the cross member. Sick. Cool. So this is phase one. I think I talked to you guys about the breakdown of how Jeff and I are navigating this, and it's really valuable for builds in general, for both parties, not just the client, but for the builder to have a goal to get to, you know, part of the learning curve here is also, you know, how do you know how much something costs if it's custom? How do you get through? How do you give a client an accurate price if you know, if you're building some crazy custom shit? And so, you know, this made the most sense. I got Jeff a pretty tight estimate that we both agreed on. And then what it does is, you know, we knew that we want to carry the same design language that's in the rear chassis and the rear shock mounts up to the front. And so that's not where we're going to build, like look at the Willys shock mounts, right? They're these organic, crazy, kind of our latest generation of design language. This is not. This is like our second generation of design, and it's very clean and tidy, but it's more platey and angular and simplified. And so I was able to present him an estimate on what I think it's going to cost, and we both agreed, like I said. And then what I can do is I can just stick to it, and stick to, you know, the boundaries of design where it holds me accountable to falling in that timeline and the budget. Or if I decide to go over, then I'm going to have to eat it, and it's comfortable for the client because he goes, well, we talked about it's going to cost this much, and that's that, you know, and we go from there. So there was additional things for sure that were talked about as we go through them. You know, we want more up travel with the cross member. It's not designed for the up travel we want, so we need to notch it. We need to, you know, cut into this thing, and we need to replate some areas. The steering tie rods, that are, well, not the tie rods, but the knuckle, the steering knuckle on the spindle was also something. You know, I didn't know when we cycled the steering if we needed to adjust the location of the steering knuckle on the beam ends. And that was a variable, so I left it as a variable, and you know, we ended up having to do that. But again, that was all cool because it was talked about stuff. So this is the phase one that I'm talking about with Jeff, is that we wanted to go through and do the basic foundation, right? Get, you know, the original intention was, even with the Carrie very early on, I went out to Jeff's shop, Juicy Motorsports in Georgia. Originally, it had a makeshift cross member under here that was locating the beam pivots. It wasn't completed, and that was one of his first things. He's like, the steering was weird, it was unstable. He had an accident in Barstow with it. He's like, I just really want it to feel safe. So our cut list originally with this was doing the instrument panel and the dash and all that, doing the front end, getting the front completely dialed with all the steering. There was no provisions for steering on it yet. There was just a 3-hole pattern for a steering gear. And then I looked at the back, same thing. I'm like, Jeff, this thing doesn't have the up travel that it's supposed to have. It's not going to function right. These cars, to me, it's a huge important thing to have the up travel at ride height. So we set that up in the rear. Then that went into everything, right? Safety, extending the chassis, putting a big ass, it's got a 75-gallon fuel cell in there, getting all that dialed, and then boom, we land back here. This is, like I talked about, this is doing something different. So there's no steering gear or steering box. There's just a rack and pinion. This is a big 2.5-inch Howe Performance rack. Jeff, thank you for everything, seriously. This is going to run a Howe pump, Howe pressure relief valve, and a Howe servo. This whole thing it's simplified. So now instead of having a steering gear and a ram assist, you just go right into the rack. The rack is a direct drag link that goes into the swingers down here. The swingers themselves are going to turn into stainless steel billet units. I do need to trim some fat off this because it's rendering a couple shapes and like an extra hole in there that we don't actually, that it's not occupied. So we want to get the shapes right. Almost got, I think part of what I was talking about also was the steering knuckles on the beam ends. We did need to recalibrate these, but we didn't recalibrate in a way where we adjusted, you know, how far out they are or anything. That was the one thing we didn't want to do is get the ratio to be slower. So all that's happened here now is we retained the top tab. Okay. We retained the top tab, and then instead of having the rod end on the top, we just moved it to the bottom and then boxed everything back in. Got the cross member welded in. That was a big gnarly unit. Welded that on the table. There was a lot of extra meat left, where then we could square it into the car and trim it to fit. Engine was already ready with the mid plate, and then, you know, the next win here is figuring out how to maximize the travel. This is a 14-inch stroke setup in the front, so, you know, we're not trying to buy new or more parts for Jeff's Bronco. This is what he had. Traditional, I would say traditional beam setup is a 14-inch coilover and a 16-inch bypass. This is just a 14 and a 14 and a 2. You know, 2-inch diameter and a 4-inch stroke. So we'll probably shorten the stroke to a 2.5 or a 2. But this is turned into maximizing the travel with what we have. So I think this is at 21 right now. We have all the axles in here. We've set it up for articulation and put it into every single form of bind we can get, and it's working. This is completely unique setup. It's a Gearworks 10-inch in the front instead of like a Dana 44. Like Cho beams and a lot of TTBs are still running a Dana 44 or like a Dana 50 interchangeable thing. This is all Super Duty F450 unit bearings, F450 drive line put into a Gearworks 10-inch. So it's robust, it's badass and strong. This thing should be able to run in 4 high at speed instead of just use it as a, you know, get out of jail free card for, you know, if you start to get stuck or something. With the steering, we just had one area here. Joe, if you look through here, this is our mock-up. We wanted straight tie rods, but you can see this guy here. There's a small crack in there, maybe, I don't even know if that's 5 degrees, that, you know, clears at bump and lock. So the whole thing is this is cycled where it's at full compression and lock to lock, and it's just to clear the bolt right here. The cross member in here, and there was some issues with clearance already. So like if you look at this area or this area, like there's some trimming in here. What we did is we literally boxed more up travel. I guess, I don't know how you'd say it. We wanted to get more up travel than what it was, and from stock. The terrible part with the Broncos or any kind of TTB setup is at ride height, the pumpkin usually interferes with the frame. And so they have limited up travel at ride height, and you always see like a lot of the TTB Broncos, if you look at the shock shaft showing at ride height, they're almost in their bump zone, like their compression zone, the last 4 inches, or it's super close to the, you know, the bump stops, and they don't have shit for up travel. And so we wanted to maximize this. We're already so deep into this thing that it didn't make any sense to not get as much of a win as possible with the up travel. Other things that we had to clearance, you know, this area here, the rack slides almost all the way out to the end here. All of the plating, this was here. Obviously we had to make some provisions, but all this stuff I re-welded the best I could. And then, you know, we added overlays here. This is the limit strap mount, bump stop mounts, Igor, Triton Engineering tube connectors. And then, you know, we dressed all this area. So, you know, we retained this mount, which is the bypass mount now, but this actually used to be the coilover mount, and the bypass was up front. And so, you know, when you take this portion, you know, this radius arm is obviously swinging at a ratio. So just like a trailing arm or a 4-link on a truck, you know, the closer the shock is, you know, towards the pivot point, the greater ratio you have of wheel travel. So, you know, the more, like when I built Chris Vaca's truck, or at least his front suspension, I built radius arms that were pocketed like a trailing arm, and they had not just the coilover mount on there, but they had the bypass mount on the radius arm like back here, and so it maximized the wheel travel for the front. So something, you know, we did is we kept that, which used to be the coilover mount, and then we just swapped it, bypass in, new coilover mount here. And that got us what we wanted. We also got some serious wins with the angles. I always strive for this. We wanted to keep the hydro boost where it was. Just again, it's trying to preserve some of this so there's not so much collateral damage where we're redoing stuff that we don't need to. But you know, if you start looking, we try to get a lot of wins with symmetry, right? So shock angle, obviously, bump stop angle, the tube work angle in line with the bump. You know, obviously the bolts, so the way the bolts rip, you know, and then same with the shock mounts. So these are actually pretty involved shock mounts. And what I mean by that is they're interlaced. They're not just like a plate here and welded. You know, like this is broke, this guy is broke, but then the mains, like this main, goes all the way through, grabs this tube. This main grabs this tube all the way through, and then this main tab for the coilover, it breaks on the top, and then it runs over and connects to the bypass mount. So there's integration that's happening where these things are all like interlocked together. Luke built these. He built this whole thing out. I welded it, but you know, it's a great exercise for Luke too, because it definitely pushed him. Getting these things, and same, you know, look at the bolts, right? Like everything is in line and everything's swinging accurately. So like there's a lot of alignment. Beams throw you for a really weird ride to get everything proper. And we did, you know, we took the time to get this stuff right. And, you know, now you can kind of feel it in the setup. The other thing we wanted to strive for, and I think I talked about it before, is to not have an engine cage that's all this crap out here, because really you have to look at this in the layers. This is your main meat and potato of structure and foundation. It protects the engine. It offers all the strength to tie in the roll cage and to support the shocks. It dives down, it supports the bump stop, and then it dives down and supports the cross member, but it terminates right before the engine. We made sure this tube was high enough so the intake can clear, and then we left all this space. Knowingly, we left this space because now we know there's a cooler package that goes here. There's a grill package that goes on here, and there's a lot more structure, but I like to build that as a sub-assembly. It's good for a lot of reasons, because if you have, you know, worst case scenario, you have some big gnarly crash, all of, you know, this sub-assembly that you're gonna see built out here, it's gonna come off of like a bulkhead, right? So there'll be a bolt register here, maybe even something cool here where it crosses up. But this will come off here and it'll probably be bolted here. So these guys will have their own structure all tagged in. And what's nice is, like, if you have something gnarly happen, you can just replace this system and you're not replacing a whole bunch of chassis. The other thing is, for serviceability, you could just unplug, you know, say there's 6 bolts max, maybe 4. You can unbolt all this and take that whole assembly off. Just like Robbie's, you know, race cars, and I think a lot of other race cars kind of have a sub-assembly of coolers in the front. You can take that whole thing off, set it down somewhere, pop this cross member out, and you're wide open. So it makes the most sense, and we wanted to do something different that wasn't traditional. So, you know, the miters on the A-pillars, they run through, and they dive into this guy. You know, this supports everything. This lets your intake come through. And there's still kind of a dynamic move going on. You can see even the angle of the bumps. When the shocks go up, they kick out more. So when it's at ride height, this angle of shock right here matches the angle of the bump stop, because the bump stop's fixed. So everything has a really nice symmetry hit. Same thing with the reservoirs. So these are 4.5-inch fin reservoirs. This guy fits nicely right here, tucks in, clears everything. and clears when the car, you know, is at compression and lock. So we tried to get as many little wins as we could. You can see, I think I started talking about this stuff earlier, but you know, this is your strike pad. That's 1/2 inch steel, boxed in, you know, double sheared limit strap mount. So you're running double limit straps, you have a little spacer in between. Going up to here. Same thing, rewelded all this stuff. They used stainless rod on this one, so it came out a little different color. And then, you know, the knuckles is what we redid. So we're at a point of completion for stage or phase 1. Like I said, there's going to be a phase 1.5, if you will. And what I mean by that is getting the revisions going for, like, see this swinger? So this is these are the occupied mounts and holes, you know, or pockets. This whole deal with the extra hole in here and stuff, and there's a lot of extra meat up on the swinger. I think I can draw some strength from running more volume or more mass of something over here and have it draw through and come back out. Have a cool little spine in there or something where we're not running a, you know, just a bolt hole here. We really only need to capture this back one, so we can always run a bolt from here, capture it with a washer and a nut here, and then this whole area can be turned into something good that looks a little more functional. I know there was some collision. Let me get out of this thing. A little bit of collision on the rack adapter up here. So we're gonna wanna note that, and Luke's gonna fix that in the drawings. And then the next thing, so what I'm saying is for phase 1.5, it's getting all of the design work done on the parts that are needing to be machined, and then, you know, doing these tie rods. As I was showing you guys with the band, what we're gonna do is we're gonna do a little more dramatic work on here just to get some design wins, and we're gonna take this thing, think about like the most primitive, ugly way to look at it is a hockey stick. You know, like a shaped hockey stick. Oh my God. Like a hockey stick shape, and it's not a dramatic bend in here. But we're gonna machine this all out of one piece of billet. Have some design details, like some, you know, chambers or something on here. And then we're gonna do all these other portions that are just round tube out of billet. That'll have, you know, nice machined parts. So, you know, stainless swingers machined, and then nice tie rods. I don't know if these will be stainless or aluminum, but get those done. The other thing that we're gonna add to the list just on the machine work while we're at it is gonna be these steps. This was always built to have a nice machine step here. The one thing I don't like about this is the design's wrong, and I might have to just eat some hours and fix it myself, but as far as ingress or egress, meaning like getting in and out of something, design-wise, everything tells me that this wants to be cut this way and boxed in, because your foot getting in is like that, right? You're never hitting it where you're coming inside the door and then you're putting your foot here. So I think to get functional design, we need to stand on that, and that's what we do. So got to get this guy like this. So probably cut this out, add more, you know, put some angle in there, box it, finish it, and then we're gonna have a nice billet piece, some kind of grip machined into it with our logo. Phase 2, So get all the design stuff done, get that out so it can be machined, and then we start right into phase 2. Phase 2 is going to be headers and exhaust and skids. The greater challenges to me visually is figuring out the exhaust and the header package for the driver's side. There's a transfer case in there, there's a drive line that goes up pretty high. So figuring out how to get a tri-Y if we can. A tri-Y setup in here, big primaries. This is 1400 horse at the crank. It was 967 to the rear wheels. 967, Jeff? 9 something. So it's a big spicy motor, probably gonna require a big primary. I'd like to get a tri-Y. Space is so limited and it's non-existent on the interior of the frame rails, at least on the driver's side. So it's gonna have to go out there and then we're gonna have to make some sick cutout into the frame where it can smoothly transition back into the interior of the frame rails, and then come right before the axle and dump out with a nice nasty exit plan through a skid plate. So we'll have a flat plane or something where the belly pan is under there, like by the upper link mounts, and then we'll make a sick exit, almost like the Vivian footprint on the side doors. It'll be like that coming out of there, and then we'll skid everything. So not just under the car, but on the sides to connecting all the rockers and stuff will be all sealed up with skid plates. So that's gonna be the next thing to look for. Maybe do a Fab Diaries on some of the drawing on this stuff just to show it. And that's it. I really appreciate the support, you guys. Like, comment, subscribe, share our channel if you can. I'd appreciate it. It helps us. It helps us be able to do this. So have a good day.